All right, in this video, we're going to talk about section 1.4 functions. We talked about functions before, and we're also going to talk about domain and range down the way too. There is a video for that one as well. But a function is a relation that assigns each element of x with exactly one element of y. So any x value, we also call those domains or inputs, is assigned with only one y value or an output, or we also like to refer to that as range as well. So for example, that typically means we don't want to have repeating x values. So we can't have 12 comma 5 and 12 comma 17. If we have 12 comma 5 and 12 comma 5, that's okay because an element of x being 12 is assigned to only one y value of 5. And we'll talk a little bit more of that as some of these examples. So we're mainly talking about this. So we're really only worried about my domain or my x value. So we're looking from here. If any of those, if none of those repeat, it's going to be a function because every value of x would be assigned to exactly one value of y. However, we have an issue here because we've got a 3 being assigned to a 4 and a 3 being assigned to a 6. So it's not being assigned to exactly one value and one value of y. So in this case, this would not be a function. And again, that's because your x value of 3 is not being assigned to only one y value. This is being assigned to a y value of 4 and 6. Now, if this said 3 comma 4 as well, that would be okay because 3 is being assigned to just 4. In this case, look at the x values. None of these repeat. So every x is assigned to exactly one y value. So then that's a yes. We also talk about what's called a vertical line test. The vertical line test is a graphic way to show that every x value is assigned to one y value or not. Basically, what the vertical line test says is, if I draw a vertical line and it ever hits the graph more than once, it's not a function. Because if it hits the graph more than once in that case, then that means there are basically repeating x values, or those x values are being assigned to more than one y value. Now, the catch is you have to make sure you look all over the place. So when I do this, I'm going to look here. That hits once. That hits once. So I need to kind of go across the entire thing. That never hits more than once, which means this is a function. Say yes. Now I can go on this next example, D. I can draw one line down, and we can clearly see it's hitting there and there. So in this case, this looks like this is an x value of 10, which is being assigned a y value of negative 10. And then up here, I have an x value of 10 being assigned a y value of a positive 10. So I've got 10 comma negative 10 and 10 comma positive 10. So just like we talked about on the last example, and the example before, example A, that has different y values associated with that. So then that's a no. We would say that would fail the vertical line test. This example I want to kind of point out because people might say, okay, yeah, I did the vertical line test. That is a function. And over here, it looks okay. But then over on this side, you can see that this is definitely hitting more than once. So in fact, this is hitting 3 different times. So the point is, make sure, like we did in this example, make sure you go from left to right and draw a bunch of vertical lines and make sure it's obviously a function or not. So again, this would fail the vertical line test. These are having x values that are assigned to definitely more than one y value. Okay, next, evaluating functions. Evaluating functions is another way of saying you're going to plug in. So notice how I'm going from f of x to f of 2, which means what's in the parentheses is my x value, and I'm going to plug that in. Now, in this case, according to this function, there are 2 places. There are 2 x's here, which means I'm going to do 2 substitutions of what's in the parentheses. If instead you had a value like, f of x equals x plus 5, and there's only 1, you only do 1 substitution. If you had a more complicated function and there were 7 different x's, then you got to do 7 different substitutions. So in this case, I'm just going to go ahead and plug it in. So I'm going to basically rewrite this function, except I'm going to replace an x. So what I like to do is kind of take that and say something squared minus 2 times that something, and then plus 3. So I'm replacing those. So replacing means substituting, which means x is going to be gone, and negative 2 is going to go in place of those. So the negative 2 is going to go here and here. So notice that once you do this correctly, the x's are gone. And then you can simplify. So if you have a calculator, you could do that. Or I know that negative 2 squared, that's negative 2 times negative 2, which is a positive 4. Same thing over here. If I take that, that's a positive 4. And then plus 3. And so then that would give you 4 plus 4 is 8. 8 plus 3 is 11. What that also means is on this graph, the coordinate point would be negative 2 kind of 11. So on that graph, there would be a coordinate point of this input or x value of -2 and this output or y value of 11. Okay, f of t. This is just doing the same thing we just did. I'm going to replace my x's. Replace my x's. Go back here, erase that bad boy. So in this case, I have that -2, and then a parentheses, and then +3. And in place of that, I'm just going to put now a t. Now, there's not much you can do here because t squared is just t squared. And then -2t, and then +3. There's not much I can do in that case. There's that one. Now it does get more complicated depending on what you get, when this one's a little bit more. So I have to do the same thing. Still going to plug it in twice according to my function. So in this case, I'm going to make it a little bit bigger. And this is going to require a little bit more work. So I have to plug in what's in the parentheses. So I'm going to replace that with x + 2 here and here. Now it's not as easy as taking x squared and 2 squared. You cannot take a binomial and just square it, square this and square that. That's the same thing as x + 2 times x + 2. And then here, I'll leave this be for a second. So I'm going to have to do the distributive property here. So x times x, that's x squared. X times 2, that's 2x. That's another 2x. And then that's another, in that case, 4. Here I can do the distributive property of -2 times x, and then -2 times 2, and then I'll bring down that +3. Look for like terms. X squared's kind of by itself. So here I've got 2x plus 2x, that's 4x, and then minus 2x. These are essentially going to cancel, or I can do 2 plus 2, which is 4. 4 minus 2 is a positive 2. And then here I've got 4 minus 4, which is 0, and then plus 3. And so that would give me that one. So they can get more complicated as well. Last one, this is what we call a piecewise function. So this is saying the graph will look like 2x, so that line 2x, only when my x values are equal to -3 or smaller. So if I ever have a problem where it's less than -3, I'm going to use this function. If in this case, if I have a value of x that's bigger than -3, I'm going to use this quadratic. So first off, you need to say, well, which one am I using? You are not plugging them into both. So first question is, you see this x value. So remember, we're going from g of x to g of -5, so x is -5. So -5, the question is -5 smaller than -3 or bigger than -3? And we know that -5 is smaller than -3, which means I'm going to evaluate it here. So I'm going to do the same thing I did. I'm going to go ahead and replace that x. And in place of that, it's going to be that -5. And so then that will give me a -10. G of -3. So either is -3 less than or equal to -3, or is -3 greater than -3? Well, I got to go to the one that has the or equal to part. So I'm still going to plug it back in this top one. So I'm going to do the same thing. It's going to be 2 times, I'm going to replace x. In this case, I'm replacing it with -3. And that gives me -6. And then lastly, 2. Is 2 less than or equal to -3, or is 2 greater than -3? I think we can agree that 2 is bigger than -3, so I'm going to use this one. So it's going to be something squared minus 3, and I'm going to plug in that value of 2. 2 squared, that's 4. 4 minus 3, that gives me 1. So that's how you evaluate with a piecewise function.